Welcome to the Institute for Catastrophic Loss Reduction's Friday Forum for Friday, July 14th, 2023. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. This is one in a monthly webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research or other useful knowledge related to ICLR's mission to make Canada more disaster resilient. Last time, we brought you Aisha Hortaxu of the Applied Technology Council, who told us what she saw when she visited the epicentral region of the February 2023 earthquakes in Turkey and Syria. Her slides and video are available at ICLR's website, www.iclr.org/workshops. Next time, on August 18th, Dr. Tegan Hobbs will tell us about Canada's earthquake risk model. Today, it's my pleasure to introduce our speakers, Dr. Louise Arnal of University of Saskatchewan in Canmore, and Dr. Alain Pietroniro of University of Calgary Schulich School of Engineering. They're going to tell us about an effort to unify operational flood forecasting under a single national framework. What I find particularly hopeful about this topic is that poorer provinces might become better able to estimate and manage their flood risk, and that raising operational flood forecasting to the national level will engage more national resources in measuring and reducing the nation's flood risk. Maybe making flood modeling a national problem will better connect it to the national efforts for climate adaptation. Dr. Louise Arnal is a research associate with Global Water Futures at the University of Saskatchewan in Canmore. Dr. Alain Pietroniro is an expert in hydrology and sustainable water systems. Dr. Pietroniro has previously served 15 years as the executive director for the National Hydrological Service, so feel free to ask him policy questions as well as technical ones. Before our speakers begin, here's our agenda. Our webinar will last 90 minutes. Our speakers will present for about half that time, then I'll moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I'll try to pose your questions in the order they appear in the Q&A box. If we have a lot of questions, I may only pose your first question, then move on to others, then circle back to your additional questions. Our webinar is being recorded. ICLR will post our speakers' slides and a link to the video on Monday or so. So if you have colleagues who could not attend, let them know. And with that, I will turn it over to Drs. Arnal and Pietroniro. Take it away.
Thank you very much, Keith. And thank you to all of ICLR for inviting us to give this webinar today. So we were invited to talk about going towards a coherent flood forecasting framework for Canada. And we'll be talking about local, but also global implications for that transition or that move. So today I'll be talking with my colleague, Alain Pietroniro, who is here as well. But this is work that we've been doing with colleagues across both of our universities, but also other institutes like ECCC, Deltares in the Netherlands. And so all of their names are mentioned on this page. So to give you a bit of context on what we want to talk about, Canada is the only G7 country that doesn't have a national flood forecasting or flow guidance system. In Canada, in fact, operational flood forecasting is a provincial responsibility, but the increasing costs and the impacts of floods require that nationally coordinated flood prediction system and guidance. So you can see a quick chart here on the right-hand side taken from a paper by one of our co-authors, Stadnik, but also Derry from 2021, where we see that 40% of all costs in Canada between the 1900s and 2020 are attributed to floods. So this is going to increase in the future, and this is something that we need to take care of. So what we're putting forward here is that a more coherent national flood forecasting framework for Canada can enable implementing advanced prediction capabilities across the different entities in Canada that are responsible for flood forecasting already. So a bit of an outline of what we'll talk about today. Firstly, my colleague Al will be talking about hydrological/flood forecasting in Canada and how it's currently being done. Then we'll both be talking about going towards that national flood forecasting approach in Canada. So talking about advances in the science of large domain hydrological modeling, but also prediction. Talking about a new federal approach to flow guidance, and then the creation of a community of practice. And then we'll wrap up with some future directions for that transition. So first, I'll leave the floor to my colleague Al to talk about hydrological flood forecasting in Canada.
Okay, thanks very much, Louise, and thanks, Keith, and everybody for having us. So it's probably important to set a little bit of context here in terms of who does what in Canada and how it works. And so, a couple of points to register here that we thought would be of importance to folks. And maybe a lot of folks already know this, but it's pretty clear from our constitution that provinces and territories have the mandated responsibility for water resources and its management, right? So the BNA Act way back gave the provinces that responsibility. And so, there's really no debate about that actually at all levels of government, right? But through the Environment Act and the Canada Water Act and a few other acts like the International River Improvement Acts and the International Boundary Waters Treaty Act, there are places where the federal government can actually work on water-related issues, right? And so very specifically on the international and transboundary side, all of the management goes through the International Joint Commission, and ECCC is the lead agency that deals with the treaties across the transboundary for most of the treaties across Canada. There's also some transboundary rivers within Canada. If you think about the Saskatchewan River System, or if you think about the Mackenzie River System or the Ottawa River as an example, right? These are all basins that are interprovincial in nature. And so often the federal government is asked to intervene somehow in either providing flood forecasting or water management expertise, typically with a board or some type of structure that respects the individual jurisdictions, but also sort of assists in making sure that there's no disputes, right? So within the Environment Climate Change Canada framework, the Met Service, so where you get your weather forecasts, actually the National Hydrological Service is contained within that. It's mostly focused on water measurement. So the Water Survey of Canada is a big part of the National Hydrological Service. But a lot of the transboundary water work and some of the engineering work that gets done with respect to water management is through the National Hydrological Service as well. And so that group, basically the Met Service and the National Hydrological Service over the last, since about 2018, has started thinking about how do we bring together something within Canada focused on forecasting and prediction. And some of the slides further on will describe a bit of that. And as I mentioned, there's two federal boards for flood forecasting in Canada. So one is the Lake of the Woods Control Board. That's an agreement between Manitoba, Ontario, and the federal government on actually doing forecasts for Lake of the Woods. And the Ottawa River Regulation Board, that's an agreement between Quebec and Ontario. And the board there is actually responsible for issuing flood forecasts on the Ottawa River because the river itself is a transboundary river. So next slide, please, Louise. So one of the challenges we see in Canada, I mean, first of all, Canada is a very, very large place, and the hydrological process is very widely. So if you think about where I am in Alberta, right, it's a mountain-driven, snowmelt-driven regime. You go to Saskatchewan, well, most of the water actually comes from the mountains in Alberta, right? But in the north, it's boreal forest and shield-dominated. Manitoba, as everybody knows, has a long history of flooding through the Red River, right? And so that's a northern flowing river. BC's had its challenges over the years as well, right? And so there really is a large diversity of sort of flood generation mechanisms across the country. You look out east, they have very flashy rivers in Nova Scotia, right? So the lead times are very short. You look at a place like Saskatchewan, for those of you familiar with the place like Prince Albert, right on the North Saskatchewan River, you have days watching the flood move downstream from Edmonton, let's say, right? And so the challenges are very different, and models and the way people approach it are very different. To add to that, I think, and everybody recognizes this, climate change is really imposing some interesting challenges in terms of what's happening with respect to flood forecasting. We certainly see an impact on flood frequency, on extent and duration, right? We also see interesting things happening in terms of snowpack and how that's changing, and how that's changing the actual regime itself, right? So all these things make it that much more complicated now to predict what's going on. So we can't always use sort of historical events to understand what may be happening in the future, right? And so this is why, we've been advocating, I guess, for a national system, both when I was with the federal government as the executive director, but also as an academic. I think there's a real need in Canada to kind of bring things together. So next slide, please. So historically in Canada, and it's still true to a large degree, this is a busy slide and you don't have to read everything, but it has been managed and is managed by the 13 provinces and territories. In some cases, there's municipalities as well that do their own forecasting. In the case of Ontario, where there's the conservation authorities that are largely responsible, right? Even though there's a sort of a provincial network or a provincial entity that's in charge of flood forecasting for the whole province. Often these entities operate independently, and they really vary in terms of capacity, expertise, priorities, roles, and responsibilities. And so, you look to a place like Nova Scotia, and I think there's maybe 2 flood forecasters on staff, and you look at a place like Quebec, and it's a whole team. And so there's different levels of, I don't want to say sophistication, but different levels of efforts across the country, depending on where people are located, right? And then when you look to the north, there really is very little. So a place like the NWT, they really don't have a flood forecasting system. The Yukon is starting to develop one, but they don't have one in place. And so, a lot of these folks, have adapted their local knowledge and local systems, and it's all working. It's not broken or anything like that. But you have to wonder about economies of scale and economies of technology, I guess, in terms of making best advantage of things. So, our view is, and certainly when I was with the federal government, the view was that the fragmented approach can lead to maybe slow adoption of new technologies. Often in these institutions, these flood forecasting groups, they're so busy literally putting out fires in terms of their responsibilities that they don't have a lot of time for development, right? And so in our view, there was a role maybe for the federal government to help, assist in kind of a cooperative federalist kind of way to move things forward. And so that's where we've made some efforts on the federal side and on the academic side to try to move the yardsticks forward. So next slide, please, Louise. So just to give you an example, and this was a paper, there was a large initiative that was led by Paul Coulibaly at the University of McMaster, looking at, basically they wrote a nice paper on understanding the landscape, I guess, in Canada with respect to flood forecasting. And so just to give you a sense, and for those of you in the hydrology world, that there's a lot of models out there that people use, right? These are hydrological models that are used to predict, what might happen with respect to a flood. And so there was basically a whole plethora of modeling approaches and platforms that were used in different provinces, right? So, and they range from all these names are just different models that people have adopted to run for their flood forecasting systems. And this gives you an idea of sort of these models and how they were, how many people actually use these models. So, if you look for the far right, you see HEC-RAS, which is a U.S. Army Corps backwater model. So that's pretty sort of standard code that's available to the engineering community. And so that's used quite a bit, right? HEC-HMS is another engineering corps model from the US, right? And that's used quite a bit as well. But some of these other models, they're very So you see they only have a frequency of 1, right? And so only one forecasting group is using HBVEC as an example or whatever, right? And so that makes it very difficult, I think, to gain those economies of scale. And for the research community, it's really hard to actually make advances because all these models are different and unique, right? And so one way to sort of, and we'll talk about this towards the end, is to develop this community of practice and develop these community-based models to really help these provincial agencies kind of move the yardsticks forward. And then, you know, what you'll see in a few seconds here is how we feel we can frame a flow guidance system in Canada at the federal level and still allow the provinces to maintain their mandates and move things forward. So yeah, so that gives you hopefully a flavor of what things look like with respect to the Canadian landscape here. And I think the next slide is yours, Louise, but let's just double check. Yeah, so.
Yeah, thank you all for giving us that context. So now we'll be transitioning to looking at what advances are being made in the science of large domain hydrological, but also flood forecasting. So there are some drivers for change in forecasting that are already being felt since the last decades. And they're due to a range of factors, but we put a few of them down on this slide. So one of them that we already mentioned is, of course, climate change and resilience. And the fact that this is happening is accentuating the demand for more reliable and accessible local information and predictions for longer lead times as well, so we can better prepare for those extremes. There is also an increase in the technology that we're using now to model, but also to predict water flows and what extreme events will happen. And that is essentially giving us new opportunities in terms of predicting things with more accuracy and things being more predictable. But yeah, also having that localized information essentially to take action. So that relates to the digital age, which is the next bullet point, where as we're in that digital age, there is an increase in the demands from society, but also clients and stakeholders in their expectations for the products that we're delivering as a community. And then there are also new methods that are out there and gaining more and more interests from the community, such as artificial intelligence and machine learning, that people are exploring to be able to predict weather, climate, and hydrology for better decisions at the end of the day. And then the last one is also very important, is that in this open government kind of era, governments are placing a lot of emphasis on open data and services, but also on partnerships and collaborations in order to boost for Canada, the Canadian economy, and to be able to tackle all of these issues globally, essentially. We're not isolated, and Canada is feeling a lot of things that a lot of other countries around the world are feeling. So talking about the way that floods forecasts are produced, so we've transitioned in the last decades due to this increase in technological and scientific capacities from land models that you have on the right to Earth system models. So if I take those two apart, land models or terrestrial system models essentially represent the flow of water on the ground, but also in the ground as groundwater, as soon as precipitation has hit the ground, right? As soon as snow has touched the ground or rainfall has touched the ground, we can try and represent with mathematical equations how that water will flow and where it will be in X days. But through these technological advances, we've gone towards something that is called Earth system models, that's on the left-hand side. And that is able to represent dynamics and processes, including the water cycle, from the top of the atmosphere down to the bottom of groundwater systems. So we're able to essentially represent vertical as well as horizontal exchanges between all of these different levels that we're representing around the Earth. and essentially able to better represent that water cycle that is allowing us to better predict floods, droughts, but also atmospheric dynamics, essentially. And more recently, large forecasting groups and modeling groups have moved towards something that is called digital twins of the Earth. So that's moving a step beyond, where we're taking this Earth system model, but essentially representing all of these processes at a very fine resolution that enables us to represent them a lot more accurately than we've been able to, producing hundreds of ensemble members instead of one prediction. So that enables us to capture that uncertainty in the predictions that we make, but also to be a lot more accurate about what is going to happen where specifically. So if we look at other large domain operational flood forecasting systems around the world, there are a lot. And I've put here screenshots of just a few of the ones that are out there. So you have on the top left, the National Weather Service forecasting system from NOAA. In the top here in the middle, that's the Global Flood Awareness System, or GLOFASS, that produces forecasts for all of the world. And I took a snapshot here for Canada from a recent forecast. On the top right-hand side here, you have the Australian system from the Bureau of Meteorology. On the bottom left, this is the Deltares GLOFASS system, again, that is global. In the middle bottom here, you have the European Flood Awareness System. So that is a version of GLOFASS that is just for Europe. And then the bottom right here is the Swedish forecasting system, worldwide HYPE, that also produces forecasts for around the world. So this is essentially just to highlight the fact that there is a wealth of data, not only in observations, meteorological and hydrological observations, but also in terms of forecasting systems that are out there and that people are able to use in Canada. So this is something that we have to keep at the back of our minds when we talk about building a community of practice, and how we should essentially do flood forecasting in Canada, knowing that there are all of these systems that already exist. So now I'll give the baton again to Al to talk about the Global Water Futures program more specifically, and research in that.
Yeah, great, thanks, Louise. Yeah, so just to provide maybe a little bit of research context here. So I think what we described just earlier was sort of at the local scale. So at the provincial level, there's these what we call bespoke models that are used, right? And so there's some research efforts we did in GWF to help the provinces advance some of the technology and some of the engineering and science required for those level models, right? But we also, we're fully aware of these global systems as well that Louise just mentioned, right? And so Canada's developing its own. We'll talk about that in a second, but we want to contribute to that body of knowledge as well, right? And so our efforts were kind of twofold, I guess, with respect to some of the research done in GWF. For those of you who don't know, Global Water Futures is just a kind of sunsetting at this moment. So it's got about another year. COVID was always a bit difficult for the research community, right? And so we're transitioning to kind of a synopsis year this year, but Global Water Futures was led by Dr. John Pomeroy at the University of Saskatchewan, right? And it was the biggest global R&D project, I think ever, actually. It was really focused on a whole bunch of things with respect to water resources and climate, and one of the efforts we focused on was forecasting. And so we had a research group, a core research group focused on forecasting. And so I'll just present some of the things we did, I guess, out of interest in how we move things forward. So there were kind of three focal points for our research. One was system development for flow guidance. So this is looking at the larger scale that Louise just mentioned, right? Is there any way to downscale or look at numerical weather products and do sort of large scale hydrological modeling, and how can we improve that for Canada? So that was one research focus. The other one was strictly on hydrological forecasting development. So some of the critical topics, again, things like data assimilation. So how do you take observations in real time update your model states and make a better forecast, right? So efforts like that were looked at as well. And we also looked at some test beds for hydrological prediction, right? So can we set up small basins across Canada? We had a bunch set up with GWF, and how can we use those to improve prediction? So we'll just go over a few of those quickly here, just to give you a flavor for what sort of gets done in the research world with respect to flow forecasting and some advancements. So we can move to the next slide. So, one of the things that I mentioned this earlier is currently the Yukon doesn't really have a flow forecasting system. They have a flood forecaster who essentially looks at the observations and does routing of the system and tries to understand, what the impacts are going to be downstream, right? A lot of communities in the Yukon actually live in the floodplain, right? But they don't have a formal flood forecasting system. So they look to GWF to help develop one. So what we did as a bit of a test program with the Yukon government was develop basically a quasi-operational flood forecasting system that produced flows on major points of interest for the Yukon government. We based it on Environment Canada's hydrological modeling system, and we used the numerical weather model from Environment Canada to do the atmospheric projections or the precipitation projections for what's going to happen for the next 3 days to 5 days to 10 days. I won't go into too many details, but the system that we developed or used was called MESH. It's a hydrological model that was developed based on kind of the Canadian global circulation model. It's a model that's actually been adopted by ECCC as well, right? And they're operationalizing that model as well for the whole country. And so we took a hybrid of that model and tweaked it, I guess, to work for the Yukon Basin. So that was one of the projects. And so now it's a question of, how do we actually move this into an operational setting? Who does it? What's interesting here is we actually ran the model on the Amazon cloud. It was actually relatively inexpensive to do that. And so we automated the system so that the outputs would get emailed directly to the forecaster in Whitehorse. And so they could use this to make decisions about what they wanted to do further on. So we're pretty pleased with that. And in a couple of cases, we really did give some good advice, I guess, with respect to the model to the Whitehorse forecaster. And so actions were taken. So next slide, please. So another topic that we've been focusing on is snow data assimilation. Canada's a cold place still, despite global warming, and so we still have a lot of snow. And so estimating seasonal snow mass is really a challenge in Canada, right? There's not a lot of people globally that work on this. So we're seen as a lead place in the world focusing on snow. And so one of the systems we've been focused on, this is the work done by Dave Casson, who's a PhD student at the University of Saskatchewan, looking at data assimilation test beds using a model called SUMA, which is another one of these global models that's around, right? And so the idea there is to look at remotely sent snow data and in situ data. So, snow pillow data that's available in real time, right? And how do you adjust the state variables in the model, right? So what happens is typically is a model will use precipitation data that comes from ECCC or comes from various stations, right? And there's a certain amount of snow that falls on the ground. Well, what happens to that snow, right? Well, it gets redistributed, it sublimates, all kinds of things happen to that snow. And so what does the snowpack actually look like on the ground? Because that's going to drive the spring freshet, right? And so we use observations that in real time to kind of readjust what the snowpack actually looks like, right? And so there's a lot of effort in Canada and through GWF to look at the best ways to kind of adjust the state variables of snow in our models. So that's just one research area that we're focused on. Next slide, please. We actually did operationalize the snow data assimilation system in the Yukon. So again, going back to that mesh model, we tried basically what we did there was adjusting the precipitation that was observed If you actually look at the precipitation networks we have in Canada, they're pretty sparse actually on when you compare it to, let's say, the World Meteorological Organization standards, especially in the north. We just don't have a lot of stations. We don't have them at high elevation. So we really don't know how much it snows. But the Yukon does have some snow pillow information, right? And so with the combination of the precip data and the snow pillow information, we were able to actually adjust the precip and come up with a new snow field to initialize the model and then do the forecast. So that was a successful experiment that we did through GWF as well. Next slide, please. Another really interesting sort of advance that we made was and this is mostly Dr. John Pomeroy, but with the assistance of Chris Marsh, who was a research associate in Vincent Vianney at ECCC, was to develop this snowcast product. So it's really focused, the domain is focused on Western Canada for now. It's a highly physically based, high resolution model that looks at, that estimates the snowpack distribution. So if you take precipitation inputs and then look at things like slope and aspect, so south-facing basins will receive more energy, so they'll melt snow quickly, right? You have issues with blowing snow and snow blowing around between mountaintops down to valley bottoms. You have issues with snow blowing into forests, right? And all these issues that kind of redistribute the snow, and some of it will sublimate back to the atmosphere. Some of it will get caught up in the canopies. All these things that happen with snow. This model really is a physically based model that tries to do that, and does that at a very, very fine scale. And so this model basically gets the snowpack about right at sort of t equals 0 at a current time, and then does a projection using a 2-day forecast and the outputs coming out of the numerical weather model coming out of ECCC. And so this is quite a unique product. It's only focused on snow at the moment. And we actually talked to our colleagues in the Forecast Center in Alberta and said, have a look, see what you think. And so they've actually looked at operationalizing this system into their forecasting, right? So they're now able to use something like Snowcast and update what they think the snowpack looks like, right? Which is really important for them, both from a seasonal forecasting perspective, because they want to know the volume of snow that's there, because that ends up in the reservoirs for irrigation, right? And they also want to know, depending on the timing of the melt, what the potential for flooding is. And so this has been a real success for GWF, right? And we'd like to move this into an operational setting as well. So next slide, please, Louise. So on the sort of more riverine basis, and I'm sure a lot of you are aware of this, ice jam floods are an issue in Canada, particularly for northern flowing rivers, right? This is courtesy of Carl Eric Lindenschmidt, who's a professor at the University of Saskatchewan, showing you sort of the magnitude of some of these things. I actually got to witness an ice jam formation many, many years ago in Fort Simpson. It really is a dramatic event to see these big hunk of ice start breaking up and going down the river, right? They don't happen frequently, but they do happen enough that they are a cause of concern. And so Carl was focused on looking at how we can improve ice jam forecasting in Canada. And so some of his work, if we go to the next slide, Louise, was really focused on forecasting real-time river ice breakup. Often we just use air temperature as a proxy for figuring out when the ice is going to break up. But again, going back to the numerical weather system within ECC, we use the global deterministic forecast, right, to actually predict potential ice jam floods with a 10-day lead time, right? So this is quite unique. And so Carl Eric did a really nice job in putting this together and actually set up a system, tested it operationally in the Athabasca River in 2019. And of course, does experiments to hindcast what's going on. But just another example of taking the numerical weather output products that are developed by ECCC on an operational basis. Most of you probably realize that the numerical weather models are pretty much what's behind most of the weather forecasts right now, right? And so we take the numerical versions of those and run them through our hydrological models to do things like this. Next slide, please. So I guess it's over to you, Louise. So
yeah, I can speak to that slide. That's my work as part of Global Water Futures. And going back to Al's point about using snow information in order to predict here volumes or river flows, what I've been doing is essentially using data for snow data, but also river discharge data for all of North America. So using HYDAT and USGS flow data, and then in terms of SWE, using the recently new CAN-SWE data sets, as well as SNOWTEL and other snow survey data in the USA. And the way that I've been building these forecasts here is building a reproducible workflow that does data-driven forecasting, so based on snow information in order to predict river flow, to explore whether that information in the snow water equivalent data can be used as a reliable predictor of future stream flow. So at the bottom here, I put a quick overview of the workflow. We first have a regime classification here that is essentially to tell us whether the basins that we're looking at are snowmelt dominated or not. We retain those that are, and I'm showing them on the map on the top right-hand side here in dark blue. So we've retained through these various different criteria for retaining basins, 75 basins. We also need basins with enough data sets, right? That's why we're reducing the data set by quite a lot. But that's enough to tell us what's happening in terms of using this type of forecasting approach. And then we do some data preprocessing, because as probably you all know, there are a lot of gaps, for example, in the snow data sets. So we have to fill in those gaps first. We have to turn these daily stream flow data into volumes that would be of interest to decision makers. So January to September volumes, or February to September, and so on, as we get closer to the summer and to September. And then we do the actual forecasting, and we verify how good we were in the past in order to be able to tell something about the quality of this forecasting method. So on the bottom right here, I put a small plot of how good these types of forecasts are for all of these 75 basins. So you can see in the different colors, you have the different target periods that we're trying to predict. So as I said, the dark blue, for example, is January to September river flow volumes. And then the purplish color is the September flow volume. And this is looking at the quality of these forecasts for the past, made with 0 to 8 months of lead time. So that means that we're, for example, for the September volumes, if we're making those predictions with 0 months lead time, it means that we're using SWE information on the 1st of September. If we're making them with 1 month lead time, we're making those predictions with information of SWE on the 1st of August, and so on and so forth. And here the quality is explained in terms of KG. That measures essentially the bias, correlation, and variability in the observations and in the forecast, trying to capture those observations. So we want to be above that dashed gray line here. And what we can see is that overall, we're good-ish for certain target periods at predicting them. For the first, say, 3-4 months of lead time, and then we decrease steadily to get closer to that dashed line, which means that we don't have much quality that we can provide in those forecasts. And then another topic that some colleagues around me have been working on, one of them is Dr. Wouter Knoben, also working on the Global Water Futures program, is community modeling, and Martin Clark is also a big person working on that. So he's the person leading the team that I'm part of at the University of Saskatchewan. Here, what they're tackling is going towards community modeling, because there exists, as Al mentioned, a diversity of models that are being used for various different applications. And it's difficult, we know that, to have a single model structure that's or framework that can actually be suitable for various different applications. Usually a model is developed and calibrated and tested for a specific application. It can be flood forecasting, for example, but there is lots of different applications. And so recognizing that that is the case, different models actually have very similar data requirements and process representations. So this evolution towards community modeling is trying to bridge the gap back in terms of understanding the overlaps that the different model development groups are facing, and trying to reduce the workload for individual working groups in order to be able to tackle these applications that we're all interested in answering and tackling. So there is development towards this community of practice in order to be able to share codes, practices, but also concepts across the different model development groups in order to make optimal use of the human resources that are available for that model development worldwide, really. So here the message is that we need to put more focus on the modeling framework and also on the people that are working on these frameworks rather than on single models in themselves. All right, so I think it's back to you, Al, now with the new federal approach to flow guidance.
Yeah, so hopefully this provides you a little bit of kind of context, I guess, of where things are going, right? And so, Louise mentioned earlier that the Europeans have a center for medium range forecasting, and they do forecasts. The Swedes have their own forecasting system, right, with HYPE. The Australians have their own, and a lot of them are doing global forecasts, right? And so, what's a person to do, right, when you get forecasts from everywhere? And so there's a need for an authoritative voice in terms of a forecast, right? And that, in my view, still lies with the provinces, right? And so, it's one of the things I'll mention quickly here, and we can have it in the discussions as well, is it's easy to say, well, we got the forecast right when you get it right. And so there could be a center in Europe or Italy or God knows where, right, that says, oh, we got the forecast right, for that flood in Calgary in 2013. And, and maybe the flood forecasters in Calgary didn't quite get it as well, right? But what they won't tell you is every time they got it wrong. And so if you get the forecast wrong too often, right, you lose credibility and nobody believes you. So it really is a balancing act of how do we develop these systems. And so part of the discussion we had internally within ECC when I was there, and certainly what's continuing now, is to develop a federal approach to flood flow guidance. And the reason we did that was, and I think many of you know this, is in Montreal, in Dorval, at the Canadian Meteorological Center, they run a global environmental model, right, for our weather forecast. They do it every day. It runs all the time, and it's what issues or helps issue the forecast for Canada. And so that infrastructure is fairly massive, right? It runs on a big supercomputer. They assimilate global data every 6 hours from all over the world, right, into the system. They do what we showed earlier on the data assimilation side. They assimilate data in real time. So, if let's say air pressure, in the model is systematically wrong somewhere, then they adjust it, right? And they go back in time and they do all these really impressive numerical techniques to actually, they're basically running a computational fluid model with heat and mass transfer for the globe, right? And they do it at a fairly high resolution. And so all this infrastructure exists for the weather, right? And so the idea behind this flow guidance approach was saying, well, we have to understand the land surface to get the fluxes to the atmosphere correct. That's part of what we do on the numerical weather side. Why don't we take that and use it to actually produce forecasts on the water side, right? Because we have to resolve the water and energy budget over the land. And that was the impetus for kind of moving that forward, right? And that's what all these global centers have realized 10 years ago, right? That they should start doing. And so if we go to the next slide, we'll just give you a bit of a flavor of kind of what was done. And so right now there's a few thrusts, I guess, in terms of what the federal government is doing for their prediction systems at CMC, right? So again, in the context of a numerical weather model, one of the big uncertainties we have in hydrology is how much did it actually rain yesterday, right? That's not always easy to capture, especially if you don't have a precipitation gauge. And so, about 10 years ago, we started working on this Canadian precipitation analysis product. And so what it is a real-time estimate based on the model itself, so that numerical weather model, and based on observations in real time as to how much did it rain. And so if you don't have a specific gauge within a certain location, let's say you don't have a gauge over a small community north of Calgary, then at least you can interpolate that with this Kappa product and get an estimate of how much it rained yesterday in that region, right? And so that's a real-time product, and the provinces have all adopted that product. They all use it now. They like it. And the other thing that has been done is there's been a historical reanalysis product done. So it's 40 years of basically running the numerical weather model, adjusting things like precip and temperature with observations, and coming up with the best estimate for 40 years of what the precip and temperature and humidity look like in Canada for that 40-year period on a kind of a gridded basis. Over above and beyond that, so that's kind of a hindcast or a nowcast kind of a product, right? There's also a forecasting product too. We call it Gem Hydro. So it takes the numerical weather model that I described earlier and actually adds the hydrology to it. And so it's becoming a Canada-wide product. It's an offline prediction system that tries to estimate, flow in rivers, what's happening to the lakes and reservoirs, right? And it uses the 6-day deterministic forecast. And it's going to be operational. It says operational in 2022. It's kind of quasi-operational now, right? And they're looking at making it completely operational by the end of this year. This product is largely there to feed the provincial flood forecasting agencies, right? And so some of it will be public, some of it won't, because as I said earlier, the mandate and the responsibility for flood forecasting sits with the provinces, right? And so the federal government doesn't want to make a forecast on the Bow River, as an example, right? That's going to be different than what the provinces are doing, right? So they'll work with the province to do that. And this is where this community of practice comes into play. So they're also developing a water cycle prediction system. And that's a two-way coupled atmosphere hydrology model that's basically focused on the Great Lakes, where there's actually jurisdiction because of the international nature of the Great Lakes. And so they're developing that as well. And they're also looking at hydrodynamic models. So those are hydraulic models in rivers, right? And again, the St. Lawrence River is a transboundary river where there's a strong federal interest. And so they've developed a hydraulic modeling system for the St. Lawrence River as well, right? And they've operationalized that. So those are the types of water prediction systems that are being developed sort of centrally in Dorval. And I think the point at the bottom is to make clear that flow guidance is not a flood forecast, right? And so the products that are being developed, particularly that'll be shared with the provinces, are guidance products, right? And so these large scale models can tell you maybe what soil moisture fields might look like in a basin, right? And the provinces can use that information along with whatever predictions come out to actually make their forecasts, right? And so the idea there is to have kind of a central entity run these large scale global models, right? And then have the provinces take advantage of those systems and run their bespoke models in the provinces. Next slide, please. So this gives you kind of a schematic of what the system looks like. So we talked about Kappa, right? And so there's a land data assimilation system within the numerical weather model. There's Kappa, which gives you the best estimate of precipitation that is possible in real time. All these are used to update kind of the state analysis of the model, right? And then it moves into a prediction mode, right? And so the numerical weather model actually produces a 10-day forecast or a 15-day forecast, right? And so the precipitation and other variables that are forecasted for that 10-day period are then put into this Gem Hydro system, and they produce basically the state variables like snow and soil moisture and also flow in the rivers that give you that river prediction, right? So they predict what's going to happen on the surface, and they also predict what's going to happen in the river, right? And then these products and services are then made available to the provinces and territories, as I mentioned earlier. Next slide, please. So, one of the things we focused on over the years, and certainly with GWF being one of the large research programs, certainly the largest ever in Canada, was, how do we bring things together with respect to forecasting within the federal family, putting things into operations, right? Where does a program like the National Hydrological Service fit in, right? And then where does academia fit in? So a lot of the effort recently has been moving towards making sure that what we do in academia is actually useful and usable, right, by our communities. And so, and we'll talk about this in a second with this whole notion of knowledge mobilization. But, it's one thing to write an academic paper and to say, oh, look at this great thing I discovered. And we do that a lot in academia, right? And that's fair. But how do you actually make it useful for the operational agencies, right? Because they don't have the capacity to really do a lot of the research that's required to move these things forward. So there is research capacity. So there's a meteorological research division within Environment and Climate Change Canada. There's a lot of R&D, but it's very applied R&D, right, to move the modeling forward. Right. And so what we've done with GWF and what we're trying to do and establish really in Canada, and maybe with the new Canada Water Agency, we've been asking about that as well, is to really have a research to operations to research approach within the context of, in flood forecasting in this case, but basically water governance and water management in Canada. And so that's something that we're pushing forward on, and we want to make sure that at least we give it a try in Canada, and we'll show you some examples of what's happening in the US on that front, where they've actually been very successful in getting the R2O2R sort of mantra established. So next slide, please, Louise. So, all of this leads to this whole notion of building a community of practice for forecasting, right? And so I'm not sure if folks are aware, but I'm sure the folks in the insurance industry are very aware that most of the data that are used for floodplain mapping in Canada are based on the Water Survey of Canada information, right? And so the 100-year floods or the 300-year floods are based on records that were collected by the Water Survey of Canada, and there's 2,300 stations across Canada, right? But the reality is a lot of people don't understand or know is that program is actually a cost shared program. And so the way that program works is that the provincial governments actually contribute funds to the federal government to run the stations in the provinces, right? And so, some stations are designated as federal stations. If there's a transboundary requirement, right, then the federal government basically pays for the operation of that station. But a lot of stations are provincial in nature, right? And so the provinces pay 100% of maintaining and running those stations, and the Water Survey of Canada does that work. And then some stations are considered sort of 50-50, right? Where the provinces pay and the federal government pays because there's a mutual interest in maintaining that station. So, having run that organization for 15 years, right, there was a community of practice already established since 1970 in that context, right, where it was a cooperative sort of federal approach to dealing with water management and certainly the hydrometric data that we all like to use, right? And so what we tried to do was build that sort of philosophy into something related to flood forecasting as well, right? Because if you think about it, what we showed earlier, you have this numerical weather system that really, you wouldn't want every province and territory, and most of them actually wouldn't have the funds to run 11 different numerical weather models, right? It makes no sense. And so we're trying to centralize this. So if we go to the next slide, you can see there's two things we tried to do within GWF. One is to push this idea of knowledge mobilization, so that research to operations to research philosophy that we think is important, right? we really tried to push the envelopes with making sure that the research we were doing was actually applicable, right? And so where we could, we embed researchers in with some of the operational agencies to move things forward, right? And really focus on from an operations perspective, what research needs to be done to improve operations, as opposed to, what I like to say is how many hydrology angels are dancing on the head of a pin, right? And so we tried to push that a little bit with GWF, and I think we were successful in doing that. And if you go to the next slide, part of that effort through GWF was actually hosting the first 2 national flood forecasting forums that were actually ever held in Canada, right? So you can imagine that every province has their own forecasting requirements, their own models, their own systems. They weren't really aware, some weren't, of what the federal government was doing with its national approach. As we developed the national approach, we brought it to the province's attention in 2019 and into 2021. And really through GWF and through ECCC, encouraged the development of a community practice amongst the provinces, much like we see with the hydrometric program and the Water Survey of Canada, something very similar to that, right? And we actually had participants from the US and Europe come and sort of give us their experiences with these sort of national flow guidance systems that they have, right? And so it was a way to bring people together to identify research priorities and sort of commonalities between the systems, right? And so it's actually, I left in 2020, retired from the federal government, but it's been ongoing since, right? And so that community of practice still meets. They work with the federal government, right, to try to bring all these things together and really kind of move things forward. So it's good news for Canada. So now we actually have a framework for a national flow guidance system pretty much established. It should be finished this year. And we also have the provinces starting to ingest that information into their regular flood forecasting systems. So that's been really encouraging, actually, to see that. So maybe next slide, Louise, please. So is this you or me, Louise? I think this is...
That's you if you're fine with it, and then I'll wrap up after.
So just a couple of things. So, as we mentioned, these large scale models, they really are large domain prediction systems, right? But the issue is usually at the local scale, right? And so the fact that you can run a large scale model and mimic the hydrology and the forecast what's happening globally doesn't mean a lot to somebody sitting in Calgary that is worried about whether their basements are going to flood, right? And so part of the research effort that we've been focusing on more recently, now that this community of this practice is established, now that we have a national guidance model, now that we have this community practice established, right, is how do we bridge the scale gap between sort of these large domain predictions, right, at the national or international scale with local vulnerabilities, right? So that gets it a little bit more into the sort of the socio-hydrology side of things, as well as sort of how do you downscale the information that you're looking at, right? So, and the other thing we've been thinking about is maybe a little bit beyond just flood forecasting, is these are large scale prediction systems, right? And so they can actually look at things like ecosystems as well, right? And so, do we want to get into at the large scale things like algal blooms, as an example, right? Do we want to be able to forecast those and look at those? And so part of the research we're focusing on now is kind of taking it that next step and looking at maybe some ecological issues as well that we might want to forecast. So water quality, nutrients, that kind of thing, right? To see, can you predict beach closures, those types of efforts, right? So that's an example of kind of a scaling problem where we want to bridge the scale gap, but also bridge the disciplinary gap as well. So that's kind of where we're going in the future with our research. So if you go to the next slide, what we've done is really started thinking about, okay, how do we get ahead of the curve a little bit, at least within Canada, and but also work with our international partners, right? to really take this model, if you like, for what we developed for flood forecasting and move it into other realms, right? And so, we have a lot of experience now in sort of taking these global systems and applying them locally, right? And trying to advance the research. And so these global models, things like GEM, are really the basis for a lot of what we're doing, right? And so, the next steps is really for taking all that knowledge and getting into more sort of interdisciplinary collaboration within Canada, right? So depending on the problem, right, we want to get into a bit of a loop where these Earth system models can now help us meet more of the societal needs, right? So we want our science to be a bit more collaborative, and we want to make sure we can get ahead of our accelerating, water and climate security threats, right? And so it's not just focused on forecasting; it's also looking at things like climate change, right? And looking at things like what's going to happen to ecosystems in a changing climate, right? And so really this approach that we've developed is really moving into, more of a Earth system modeling approach that deals with many multi-level issues with respect to water and ecosystems. And so we're really pushing hard, University of Saskatchewan, University of Calgary, other partners for interdisciplinary collaboration within Canada, right, to kind of further develop some of these systems. So next slide, please. So Martin Clark and myself and Bob Sanford wrote a little bit of a provocative piece, I guess, on how we move from what we've done in the forecasting realm and what we've done with ECCC in Canada to more of an environmental prediction system in Canada, right? So, how can we effectively use limited data information that we have, right, to build a state-of-the-art environmental prediction system for Canada, right? We think we have the blueprint with what we've done in flood forecasting and what we've done in some of our numerical weather models, right? So, how do we move that forward as you move into more environmental prediction systems? The breadth gets a lot larger, right? So it's no longer just hydrology, it's no longer just energy balance. It gets into things like ecosystems, right? And so you have to bring in more people, right? And so if anybody's interested, we published that paper in the Canadian Water Resources Journal, right? Just as a bit of a thought-provoking piece to see how we can take our current framework and actually move it forward, and develop a community of practice really in environmental prediction is what we'd like to do down the road. So next slide, please. So, one of the things we talk about in that article is there's a need for better links between academia, government, and industry, right? We can't do these things alone, right? And so what we want to do is and then what we challenge, I guess, the community in the article is we don't really have long-term relationships between academia and government, right? So those of us who do research, right, everything's short-term, it's 3-year grants and contributions, right? NSERC is maybe 5 years, even with Global Water Futures. That was a 7-year program, was a massive investment, right? But it comes to an end, right? And then what happens to everything we develop when it ends, right? And so the reliance on sort of these short-term projects really doesn't help us advance our community of practice, right? All that easily, right? And so what we'd like to do, and what's modeled on what we see in the US, is these cooperative institutes, right? So these cooperative institutes really allow for kind of long-term funding, right? They can bring industry and government together, right? And you really can develop a focal point for research, right? Whether it's in operational hydrology or environmental prediction. And so one of the arguments we make in that article is to, if we really want to advance what we're doing in Canada, we need to think about that, right? And it's not just for projects that Martin and I are involved with, right? Or John Pomeroy, it's really for the whole community across Canada, right? So rather than this, we showed earlier, it's a bit piecemeal when it comes to flood forecasting, right? With the provinces, well, it's very piecemeal when it comes to research as well, right? And so how do we bring it together in a cohesive way? So that article tries to talk about that a little bit, right? And so if anybody's interested, please have a look. But it's kind of a vision for what we see. And so if you go to the next slide, you see where Canada can lead in some of this, right? So we know that the expertise and capacity in environmental prediction in Canada is scattered across many research organizations group, right? And that's academia, government, industry. And so, how do we coordinate this in a real way to actually address our wicked water issues, across Canada, whether that's climate change or forecasting or flood forecasting or floodplain mapping or whatever we want to think about, right? And so there is a need to modernize the prediction ecosystem in Canada and give access to academics, right? There's a few of us that have our connections with ECC and can do things, right? But there's a lot of academics that don't. And so we really need to kind of open that up a little bit, right? And make these systems available for people to do research on and to move forward, right? So we really need to build a nurturing community of practice really in the sphere of environmental prediction, right? Where both the research and operational groups contribute, their expertise, their data, their information, right? But move towards a common goal of a better system, right? And so the idea there is to maybe look at sharing knowledge on, let's say, predicting floods, across diverse regions. That's one example, but we could also look at other environmental issues that we're grappling with, right? And see how we can bring things together. And part of that could be international collaboration, right? So I think in Canada, we have the advantage of, we have a large landmass, right? So we're really challenged there in terms of what we can do. We have pretty limited data actually in the grand scheme of things, right? But, we have a strong modeling ethos. We have a strong research community, right? So bringing them together will really kind of help us set the bar, I guess, for Canada, right, and globally where we can move things forward. And so to do that, we would work with international communities to move forward. As Louise showed, a lot of these models are very similar actually across the globe, right? And all the other agencies are moving towards these environmental prediction efforts, right? And so we could actually lead a lot of that in Canada. So just a challenge for people to think about, I guess, down the road. So Louise will now introduce a project that we're working on with the US, which is very interesting and sort of is a community of practice and a cooperative institute in the US that we're involved with. So we'll hand it over to Louise.
Thanks, Al. Yeah, so as Al mentioned, there are these cooperative institutes in the USA, and the recent one is called the Cooperative Institute for Research to Operations in Hydrology, or CIRO. And that is receiving money. So the University of Alabama, in collaboration with NOAA, are essentially forming that institute to advance water and flood prediction across North America, because the University of Saskatchewan is a partner of CIRO, and then by proxy, University of Calgary is working on a lot of the topics that we're working on as part of this big project. So it's a lot of money, right? It's $360 million US dollars over the next 5 years to tackle essentially the science and prediction of water challenges, like Al mentioned, but also more specifically floods. And if we go to the research themes that CIRO is tackling, so there are 4 main research themes. So the first one here is the expansion, but also the improvement of water resources prediction. So there is a big focus on floods, but not only, they're looking at droughts and other environmental issues like water quality. Then the second one here is advancing and accelerating the community water resources modeling that we've been talking about a lot. So recognizing that doing modeling as a community can really help us go forwards in terms of better predicting those extreme events. And then also using and advancing hydroinformatics in order to be able to better capture those events. And the last one here is bridging that interdisciplinary gap, where they're looking at the application of social, economic, and behavioral science as well in water resources to try and see how together we can tackle and improve water prediction. So it really brings together lots of different partners across the USA and some across Canada as well, from the research, but also the operations worlds, in order to be able to tackle these things together. And then another group that we wanted to mention here is HAPEX, and that's a global community of researchers and practitioners in hydrological ensemble prediction, or hydrometeorological ensemble prediction, actually more accurately. And it brings people really from all around the world, including some researchers in Canada that contribute on specific topics that relate to this overall topic here. I am a member of that community, I guess, since I started my PhD. And if you follow the website here in the top of the slides, then you'll be able to join the community as well through a mailing list and see all of the different blog posts that are out there and other resources like serious games that have been developed by researchers and practitioners in hydrology. So to wrap up here and going back to flood forecasting more specifically, so that coherent or national flood forecasting framework that we're hopefully moving towards should be developed to coordinate the local, but also the regional and international efforts that are ongoing to enable the operationalization of state-of-the-art science, but also technological advances in flood forecasting. It should follow that top-down approach for everything that has to do with large domain forecasting, but also climate change, risk assessments, and so on, but also a bottom-up approach in order to be mindful of the local realities that are affecting communities on the ground, and that forecasters, decision makers, engineers, scientists, and so on the ground are seeing and tackling for a very long time already, right? And have all of that knowledge that they can bring back to the top. It will also need to articulate the accountability and responsibility of individuals in the flood early warning chain, right? If there is a national system and then individual bespoke systems locally, then we will need to be careful in who is responsible for sharing what message, but also accounting responsibility for essentially communicating the authoritative forecast. And that's the last bullet point here, amongst all of the wealth of data and products that is available out there. So if you're curious to learn more about that paper that we wrote that was published earlier, then you can follow that QR code or look for it in the Journal of Flood Risk Management. And then that's the last slide. To wrap up more generally, flow forecasting in Canada is a partnership that requires a series of different approaches and models. So there is no national approach yet, although there is a flow guidance system being developed at ECCC at the moment. And the provinces and territories, as we said, have their own systems, and they're also retooling those systems to take advantage of the new services and advances going on. And there is an increasing wealth of global hydrological forecasts as well that need to be taken into account. So we think that researchers across Canada have an important role to assist in assessing the predictability and the quality of the information that's put out there, and to also run these custom-made implementations or test beds that are presented, for example, in partnership, obviously, with industry and governments. And one big message I would say for this presentation is that collaboration is key. And there is a need to assist in the development of a Canadian, but also a global community of practice, collaborating with other global centers or cooperative institutes. And there are also large needs and opportunities for knowledge mobilization to make sure that the science that we're working on has some application on the ground so we can tackle these weather and hydrological extremes. So with that, thank you very much, and I look forward to the Q&A.
Great, thank you so much. We have a couple of questions, but I have a big picture question that I want to throw in first.
Sure.
So the Institute for Catastrophic Loss Reduction is particularly interested in managing pluvial and fluvial flood risk, mostly for buildings, but also utilities and transportation infrastructure. So, when I, as an engineer, hear about a new new natural hazard model, I imagine someday in the future, logging onto a web page or downloading a piece of software that estimates risk and loss to people and buildings and whatnot. So I imagine tables and maps of flood extent and depth and duration, and maybe considering an approaching storm system. And I imagine going farther to estimate, to produce tables and maps of damage and monetary and human losses, all in the service of climate adaptation. Being able to do this for as is conditions. And what if I change something? What if I make a change in our flood control systems, or I make a change in the built environment, add flood mitigation to buildings and whatnot? And that all seems very far downstream from what you've been talking about today from GWF. So my question is it downstream? Is that something that is in the future? How far downstream in terms of time and in terms of money? What has to happen before we get there?
You want to take this one out?
Sure, I can give it a try, Keith. So, I mean, if I understood your question properly, and I think I did, I mean, you're dealing with sort of local realities, right? So that a consulting engineer might want to deal with, right? So let's say flood mitigation, building the banks of the river up to meet the 200-year flood, as an example, right?
Mm-hmm.
So it's not the federal government that's going to do that, right, by any stretch. And it certainly has to be local consultants or whoever who have the expertise, right? But if you're going to, let's say, try to build a climate change angle on that and look at what might happen to the flows in 50 years, right? Right now, with the consultants, as far as I can tell, and working with a few of them, they have to go down to, the CCMA website and download a climate projection and figure out how to put that in a model and figure out how to figure out what the flows might be, right? And there's no sort of national product, as an example, right, that really tells us, and none that's been approved, right? And so when you look at even things like flood frequency analysis, right, we just did a recent study looking in Alberta, right? And so, some consultants use instantaneous data, some consultants use annual maxima, they all use different distributions, right? Some of them put climate change in, some of them don't, right? All these different approaches, right? So in my mind, these community practices can actually help consolidate how we approach the problems, right? So if we can come up with data sets that are used by municipalities and by the provincial government and by consultants, right, for, let's say, climate change, right, then everybody's sort of on the same page with using these data sets, right? And so to me, that's where this sort of top down and bottom up sort of meet, right? And so then the local consultants are actually doing things based on kind of established standards, right, as opposed to trying to pull it off the web or figure it out, right? So I think that's where we're kind of coming from with this, is we need to establish these communities of practice really to agree upon, how we do it, right? Because as you know, there's a million ways to do it, right? And so and they're all kind of right, but none of them are accepted or agreed upon, right? So I'm not sure that answers your question, but I think that's how we kind of bridge that gap, right, between the local folks, right? Because there's no way at the federal level, or it's not going to be the European Center that's going to figure out there's a bend in the river, right? So I think that's got to be local, right? But we've got to give the local consultants the tools, and the students too, right? I think we'd like to train students to be able to deal with these things. So we've got to give them the tools to be able to kind of do those kinds of analyses. So hopefully that answers the question.
Well, it gets me a little bit closer there. Let me ask some of the questions that other attendees have posed. So Amir Mohammed asks, Canada is large in size and thus has significant landscape changes presenting unique challenges. Should we group regions, prairies, or Atlantic, etc., instead of national? I guess is what he meant.
Yeah, do you want me to try that, Louise, or do you want to?
Yeah, go for it. I have something to add after.
Okay, so that's absolutely right. Canada's massive, right? I mean, it's you look at the Mackenzie Basin, right? It's 1.7 million square kilometers, right? It's basically the size of Europe, right? And so when you start thinking about about how we do things. So the approach is national, right? But the models are actually, in a sense, looking at sort of regional from that perspective, right? And so, when you run, I mean, hydrological systems are kind of self-organized, right? So when you run a model for the Saskatchewan River Basin, right? Well, it becomes basically a prairie model, right? In some ways, right? Or the Mackenzie or others. And so just by the nature of hydrology, it tends to be regional, right? And so yeah, I think the idea here is you have a national system. The atmosphere is global, right? I mean, that's pretty clear. But hydrology is very regional. So yeah, we have to think of it regionally. So you're absolutely right, Amir. That's the way to look at it. And Louise, did you want to add?
Yeah, I think that's a great answer. And just adding also on, I guess, the forecasters or decision makers side of things as well, in that although they're separated amongst the different provinces or territories, or so, they do have that knowledge about regional responses in terms of what happens with the hydrometeorology and the flood generating mechanisms and so on. So building that community of practice essentially enables those people who have that regional knowledge of what happens on the ground, and it gives them a space to share that knowledge so that they can share the way that they're forecasting something or the way that they're making decisions based on the information that they have for the specific region.
Victoria Fernandez says, including Nova Scotia and Prince Edward Island, the map of flooding mechanisms would provide a complete picture of processes throughout Canada. Coastal flooding is particularly important in these areas, and they would substantially benefit from a national framework. Do you have any thoughts about that?
Sure, I can answer that one. So we didn't talk about it, right? So the impetus for generating that national flow guidance system that was done, right? That was a Treasury Board request that we made back in 2018 to get funds to develop that national federal system. Included in that was actually a coastal flooding system as well that would be run through the numerical weather folks in Dorval. So that is part of it. I didn't present any of it. If I remember right, and that was 2018 when we got the funding in. So we got $90 million, right, to kind of revamp the water survey and to actually develop this national system over 5 years. And so I think, if I remember correctly, the idea was to test it in Nova Scotia. And so the numerical weather people run, obviously, the atmospheric model for the globe, right? And then they focus it in on Canada. It's basically, they use the boundary conditions from the globe and do a high resolution model for Canada for the atmosphere, but then they run the land surface as well, right? And that gives the fluxes, but they also run large ocean models. And so the idea is there is to couple the ocean and the ocean models and the numerical weather models to look at things like storm surges and other things, right? So that's part of the system, but nothing we included.
Brett Snyder says, how do you see areas or provinces with very little resources using the flow guidance to inform their flood warnings? Does the flow guidance system provide return periods or some interpretation of how extreme the flow predictions are?
So I can try that one as well. So I think that was part of the challenge that we came up with when we looked at this, right? So some of the smaller provinces don't have much, right? Particularly in the north. And so they can almost leapfrog the technology a little bit, right? So a lot of the models in the provinces now are models that were developed in the 70s and 80s, and they're still using them. And so some of these more modern systems, I can see some of the provinces just kind of jumping into that technology, right? And working with that. So I suspect that it's their call, right? At the end of the day, it's up to the provinces to decide. But I can see them using the flow guidance system almost directly if they choose to, right? And they have that option, right? So that'll be up to them to figure that out, right? So that's the part A, I guess. In terms of the return periods, that's kind of going to be up to the provinces to decide how they want to convey the risk, right? In terms of their because they're the ones pushing things out the door with respect to informing the public, right? So it could be done. And I guess, Brett, this goes back to, this idea of a community of practice, right? So, where industry or the insurance industry can push hard if we have a community of practice, say, this is the kind of products we want to see out, either for us as an industry or for others, right? I think that's where the community of practice makes sense, right? So if it's something that's needed or wanted, that could be done, right? Right now, there's really no mechanism for anybody to say, this is what I want, right? It's really up to the provinces to decide what they're going to put out the door.
If I can add to that as well, with regards to the community of practice, something I've seen being done in Europe, for example, with the Global Flood Awareness System, or GLOFAST, that I showed a quick screenshot of. They're doing essentially, they're releasing this forecast, right? But around that, they're also building a community in that they have regular webinars like you have at ICLR, but also regular workshops a couple of times a year, so that people can join in and learn about the tools and also voice not only their concerns with how those tools are applicable for their region, but also what they would like to see in the future improved in the system and so on. So I think having something like that with any kind of top-down, bottom-up approach would make sense for this kind of system.
Okay. Chris Petullo asks, as a representative of a local authority in emergency management, my focus is on understanding if we're going to have a flood, and if so, when, where, and how badly. How far, he's asking, Chris is asking a similar question to what I was asking. How far away are we in years from being able to provide emergency managers with data to that level that we can make decisions on? Oh, and Chris also adds, thanks very much for today's presentation and the information provided. Very much appreciated.
Yeah, I mean, Louise, do you want to talk about that from Louise worked at the European Center for Medium Range Forecasting, right? So she kind of knows that world a little bit.
Yeah, that was one of the big topics of the last HAPEX meeting, the community that I talked about towards the end, because we're seeing that there are all of these global information systems, but there is a need to have localized information, right? As you mentioned, Chris. And I think one of the ways that we can tackle this beyond building this community of practice and having these interactions is moving towards impact forecasting as well. So impact-based models, where we take that more regional or global information and we feed it into systems that are able to take that and have that knowledge of infrastructure on the ground, for example, to be able to give you that inundation information or that flood impact information, also having economics mixed inside and things like that, or knowing where the vulnerable populations are situated, right? All of these things. So I think we really need to bridge that gap between the large data that we're using and more flood impact based models.
Yeah, and further to that, Chris, that I'm reading down to your other comments too, right? So, one of the projects in Cairo, which is, super interesting, is they're looking at, so the States is different, right? In the States is that the way they work there is NOAA is actually, as a federal entity, is responsible for flood forecasting, right? It's not a provincial or a state thing, it's a federal thing. And so they got whatever, 17 or whatever regional forecast centers, right? And so what they're focusing on in Cairo now is sort of real-time mapping of flood extent based on the projections for flow, right? And that doesn't really exist sort of systematically in Canada, as far as I know. And I think that's what you're getting at here, right? And maybe, Keith, that was a bit of what you were getting at too, right? So, so the technology to do that actually exists, right? It's not rocket science, right? I mean, if you know the flows, you can figure out pretty much what the levels are going to look like, right? I mean, you might not get it perfect, right? But there's no mechanism to do that in real time, right? And so for all the provinces to pull that together is tricky, and nobody quite knows the best way to do it, right? And again, going back to this idea of a community of practice, right? You should be able to actually consolidate the provinces to develop something that makes more sense, right? And so we should follow the lead of the Americans. They use this hand index and things like that, right? To actually provide these real-time things. There's no reason why we couldn't do it in Canada, at least for the vulnerable, municipal areas as an example, right? So yeah, I think we need to get more onto that, right? And then convey the risk in a way that's understandable to the emergency folks, right? Because that's a real problem. If I'm telling you the flow is going to be whatever it is, 350 CFS, right? You're going, so what does that mean, right? And we need to do better, right? And we can. Technology is certainly there, right? It just, we need to have the will to do it, right? And again, this is where I'm really hoping the water agency can help kind of, if that's a priority, right, then get the water agency to help, at the federal level, working with the provinces to make these things a reality, right? So that's where I'm hoping this all goes. So.
Great, thank you very much. We still have more questions, but we are out of time. So I'm going to thank you both, Louise Arnal and Alain Pietroniro, for your talk. I'm going to thank our attendees and remind you again of our upcoming Friday Forum on Friday, August 18th, where Tegan Hobbs is going to tell us about Canada's new earthquake risk model. Thanks very much, everybody, and we'll see you next time.
Thanks very much, Keith, and everybody.
Thank you very much.
Bye-bye.
Take care.